Using a formula to solve a real-world application. Many applications are solved using known formulas. The problem is stated, a formula is identified, the known quantities are substituted into the formula, the equation is solved for the unknown, and the problem's question is answered. Typically, those problems involve two equations representing two trips, two investments, two areas, and so on. Examples of formulas include the area of a rectangular region, which is A equals L times W, where L is the length and W is the width. The perimeter of a rectangle, P, which is equal to 2 times the length plus 2 times the width, and the volume of a rectangular solid, which is equal to the length times the width times the height. When there are two unknowns, we find a way to write one in terms of the other because we can solve for only one variable at a time. So for example number 3, we want to solve an application using a formula. It takes Andrew 30 minutes to drive to work in the morning. He drives home using the same route, but it takes 10 minutes longer, and he averages 10 miles per hour less than in the morning. How far does Andrew drive to work? Well, this is a distance problem, so we can use the formula D, which is equal to RT, which is distance, which is equal to the rate times time. So again here, where distance equals rate multiplied by time. Now note that when rate is given in miles per hour, time must be expressed in hours. Consistent units of measurement are key to obtaining a correct solution. First, we identify the known and the unknown quantities. Andrew's morning drive to work takes 30 minutes or a half an hour at rate R. His drive home takes 40 minutes or 2/3 of an hour, and his speed averages 10 miles per hour less than the morning drive. Both trips cover distance D, which is the same distance. A table, such as the one that you see here, is often helpful for keeping track of information in these types of problems. So we have traveling to work, traveling to home. We have a column that represents distance, a column that represents rate, and a column that represents time. So we're trying to find out what is the information that we're looking for. Well, here we have our distance to work, distance to home, the rate to work, the rate minus 10 to home, and the time that it takes is in half an hour to 2/3 an hour. So we're going to write two equations, one for each trip according to the table that we've just created. Remember, the distance is equal to the rate times time. So the distance here is going to be R times the time. So we get R times 1/2, which is equal to 1/2 R. To home, again, we have distance, which is equal to the rate times time. So the rate is R minus 10, and the time is 2/3. So if we distribute the 2/3 to both terms, we get 2/3 R minus 20/3. As both equations equal the same distance, we set them equal to each other and solve for R. So because they travel at the same distance, we can set D equal to D, which means then we have these two formulas that we can set up equal to each other. So we have 1/2 R, which is equal to 2/3 R minus 20/3. So, going back to our previous exercises, we can see that we have three terms, and we can see that the LCD is 2 times 3, which is equal to 6, and we're going to multiply each term by the LCD. So we have our original equation, 1/2 R, which is equal to 2/3 R minus 20/3, and multiplied by the LCD over 1, which is 6/1. And then we simplify. 2 goes into 6 3 times, so it's 3 times R. 3 goes into 6 2 times, so it's 2 times 2 times R, so that's 2R times 2. Minus 3 goes into 6 2 times, so we have 20 times 2. So we have 3R, which is equal to 4R minus 40. Isolate the R on one side, subtract 4R. 3R minus 4R is negative R, which is equal to negative 40. Divide both sides by negative, then R is equal to 40. So we have solved for the rate of speed to work because R represented the speed to work. But we also need to find out what is the speed to home. So substituting 40 into the rate on the return trip yields 30 miles per hour, now we can answer the question, substitute the rate back into either equation, and solve for D. So for D, it's going to equal the rate times time, which is 40 times 1/2, and therefore the distance is equal to 20. Therefore, the distance between home and work is 20 miles.